Okay, first thing we're going to do is start a new project with Logix Designer. Double click the icon or start from the menu. Okay, now the project's been, software's been started, we do a new project. We can either click this button right here or we go up to File and click on New. We're going to pick a processor, which is, I have this one here, version 20. We're going to give it a name. Usually something that's of value here. Pick this one right here. And then we have to pick a directory. This is where I'm going to go here. Okay, hit the OK button. I have a project already, so I'm just going to overwrite it. So, new project. And it creates a new project. And if you don't know much about Rockwell, you have controller tags, which are global scope tags that you can add. Then you have, and then we have a main task, a main program, and this particular program has program tags, which are scope only to this routines in the program. And then we have the main routine. The main routine is called cyclically. You see here that the assigned routines, so that main routine is called cyclically. And normally this main routine here is set so that you call subroutines, other routines from that routine. And the next step in this routine is to add a connection. So the purpose of this project here is, as we said here, we're going to use Telegram 1, which is velocity or speed basic. And we're going to be adding the connection to the CMMT controller that we've already configured in the Festo Automation Suite. So right click on EtherNet. If you have a different processor, you might have to add an Ethernet master. But basically you right click, go to a new module. I've already registered the EDS file, which is for the CMMT. And depending on your version of software here, simply do a search. So I've got 2 EDS files installed here. So I'm going to pick the CMMT here. Click on Create. Okay, so first thing we do is we give it a name. I have some predefined names here. The IP address is 185. I can show you again in Festo Automation Suite where that's set up. So under field bus settings, Ethernet IP interface is right here. And down here we need to change the connection definition here, and we're going to select an integer type, and I always like to do exact match. It's up to the user. Hit OK, yes, change. Then connection info. The CMMT can go as low as 1 millisecond, and unicast and cyclic. Depending on your project size, of course, you would not use 1 millisecond, but I just have one project, one controller. And the other protocols here, nothing been really set up. Okay. So we can close this. So now we have this connection set up right here. And we're going to pick a PLC here that we're going to use to connect online with. And we see here that the processor 119 is available. I'm going to set the project path. And do a download. And we can see here I picked the wrong processor type. So let's just take a look again. Yeah, look at the processor type. And it changed the processor type, so we're going to do a download now. And it didn't like the empty brung, which I thought I deleted. You'll see here that it changed the controller here. So now we've already selected the path. We can just do a download now that I fixed that error. And we're in program mode. Put it into run mode. And we're good. So we've proven that we have the connection, no problems, no errors, no exclamation marks, no faults. There's our module info here. Okay, so everything's good there. So we can save the project, go offline. Okay, so with this far now, the next step is to add the add-on instruction. So right-click on add-on instruction, new add-on instruction. Actually, not add-on, import, sorry. Import add-on instruction. And I've already selected the AOI here, so this is the basic speed AOI that we're going to be using on import. And in this case here, we're just going to accept all the defaults and OK. And you'll see here that it created some user-defined data types, the logic, and the add-on instruction. Next step is to add code. Okay, and as I said before, I'm going to make a unique routine for the AOI. And this is the routine we're going to use here. And you can either drag this over to here or go to add-on up here and click on this, add it on here. Okay, and next thing we have to do is add some tags. So there's a couple ways you can add tags. If you just put a tag in here, hit the enter button, and then right click, you can say new axis, and you pick the main program or the main. So this is the program scope, this one here is the controller scope. So I'm going to create that, and you'll see here that in the controller tags we just added this tag, which is of the data type basic speed, which is referencing to the add-on instruction. And then we continue to do things here. And put a couple things in here and then define them after. Okay, so for each of these tags, we're just going to do a new. And it's defaulting to the last thing that was set, and it defaults to the correct data type that you need for this. I'll just keep creating. For the more advanced users, you can, like, if you want this to be added a different way, you can simply go up here, go up to the controller tags. You see here that it added those tags for us, and we're going to do a base value speed here. The base value speed I know needs to be an integer, so you would come down here, do the drop down, and you can select int, hit OK. Okay, and this is edit tags, and we have monitor tags. So we can also put some initial values in here that are stored offline. So in this case, like the base value speed, I want this to be, well, I'll get to that in a minute, but for now I'm just going to put it in there. I'll tell you why after. Speed target, one value, and go back here. Okay, now we need to, we've got tags associated, now we need to add the raw data map, which is coming from the connection down here. And the easiest way to do that, come into here, copy that input data. I just did a control tab which switches back and forth between the two here. And so I come down here, double click, put that value in there, control tab, goes back to the previous window here. Highlight this, control tab, and now we have a no faults, and we come up to here, we can verify the routine, verify the controller, there's no faults anywhere. If I eliminate this, I'm just going to cut it just to show you here. If I do this here, you'll see that it points us to the direction that this is the error here. Okay, so we basically have a basic speed AOI installed, set up, ready to rock and roll. Hit the save button. It's going to zoom in a little bit for everyone. So we have our AOI configured here. Now, normally programmers would not add a tag for each one of these because it's really unnecessary in most circumstances. If the AOI was created right, normally you would simply use the instance name and then the period afterwards. So I'm just going to show you a quick thing about that. I'm just going to add a little bit of things here. So I'm going to drag this rung up above it here and find a, let's find a move here. So got a couple moves. If I take this instance here and then paste it there and do a dot RPM set speed, we've got that one there, and this one right here, max VM. Let's go over here. Enter. So I'm just using this as a placeholder, so this way you get to see what has been described in the AOI itself. So if you were to, right click on the AOI, open the definition, and you go up to local tags and parameters, so you'll see here that the AOI itself has description, so every one of these has got a description. And you can either use these areas here, or you can monitor them. Do the same thing for a couple of bits. Just put a no operation in there just so it doesn't do anything. And again, copy this. You can also go into the tags itself. Sorry, I'm trying to make this a little wider here. Right. We're going to pick off 3. Over here, I'm going to pick the run set point. Again, you could come through here and choose it right from this point right here. Okay, and finally, what I'm going to do here, right click, edit run comment. Just going to paste in some information I have previously defined. So now we have some information. So I just added these right here so that you guys could see what some of the bits mean. Because if you just walk up to this and you see the word off to, it doesn't really mean anything to the user. Whereas if you come up to here, it says, hey, off 1 for normal operation, deactivate for ramp stop. And then up here, I've also said, a little more description on top of what was already added to from the AOI itself. So we have this now, and we're ready to download because we have no errors. If we were to download, it wouldn't work because this code's not scanned yet. Remember, you would come through here and you would add a JSR and then call the routine. But I'll just show you how to do that real simply online. So I'm going to do a download now. Change the color in run mode. So one of the best parts of Rockwell is the fact you can do online changes. You'll see here that nothing's happening at all. And I've missed doing a couple things, so I just wanted to show you some online changes. And the first thing we're going to want to do is, as we said already, add a rung, add a JSR. You can either scroll through here, or if you know what you're looking for, you can add it manually. So in this case, JSR, and I'm going to call that routine. And then over here, this just finalizes edits. You can test edits and do things. So you can come into here, accept pending edits, and you test them. So if you want to back up, so now this would be actually happening, and now it's functioning, it's calling. See how there's information coming through here now. And if I go back to here, I could untest the edits because I don't like them, I made a mistake, and it would blow away that. But if we don't need to do that, then you can go here and they're accepted. And one last change here is that you shouldn't be scanning the I/O here if the connection is not made. So this right here, when you're using an EDS file, there's always a connection faulted. Go back to here, double click, add a nobody closed. Make sure that we don't have a connection faulted. The only time we're going to scan this is when we don't have a connection faulted. And then over here, this is the alternative, which is basically don't want to test or do anything. We know we were programming perfectly. We're going to finalize everything, one click, yes, and it finalizes everything, and everything's good. So if I actually were to disconnect the cable on the controller, which is right now, I've lost the connection, plug it back in, and so that when it's disconnected, you have the faulted inhibited, and then when you're back up and running, you're good to go again. So by default, the off 1 and off 2 and off 3 are enabled. That's because those are either coast stop or rapid stops. And first thing we need to do is clear the faults and get the access enabled. I'm just going to minimize or reduce the size of this here and bring up the Festo Automation Suite project. Okay, and this little guy right here, toggle controller, this gets rid of the stuff on the left. We don't need that right now. And I'm going to reduce the scale a little bit by holding my mouse in here and then holding the control key down and zooming out with the wheel, the mouse wheel. A little too much, but so up top here we don't need this, we just need the AOI itself. So let's just scroll in here, and if we go to the control tab, because we're online here, manual movement, diagnostics, and I can get this watch window out of the way for the time being. So this right over here gives you some indication, and over here press a 1, and I'm going to reset all the faults. Turn that back off. I'm still inhibited. I'm inhibited because I have the control sovereignty over here. So I'm going to turn this control off. I lose the inhibited. Now it's ready to start. The enable, put a 1 in here, and the axis over there is enabled. If I go to this task over here, we have velocity, active motion task, drives reference because at some point I referenced it offline. Normally if you were to start up with the velocity profile active, it wouldn't be homed at all. It's irrelevant. And I am ready to go. So I'm going to leave this open over here, and we've already discussed this, but we need to go to the Field Bus tab. Okay, the Field Bus tab, you need to make sure that the base value velocity in the Festo Automation Suite project matches the base value speed here. If you don't do that, then the values you put in right here will be incorrect. And in order to get the access to execute, the next step here is to run the set point. So if I put a 1 in here, it's going to immediately use the acceleration and deceleration values to excel up to the velocity I've specified right here. So put a 1 in here. You'll see that the set point value velocity is now 99.99, and the actual velocity is following. And from this point on, it's kind of a continuous. You can just change this value right here. It immediately changes the set point, and the actual velocity will follow it based upon the accel. And if I change this down to a 1, then of course the decel will take place, and so on and so forth. Nice and slow speed here. You can hear the motor humming in the background here. And if I change these values right here, which are immediate, and I change this to, it's a lot quicker response, obviously. There you go, very fast. Okay, so 500, so put this back. And that is the basic speed AOI functional. It's still running here. You'll see that if you drop one of these here, that it will continue to run. Let's just try the coast. So this one right here. So if we drop the coast stop, it should theoretically take a little bit of time to stop. So I'm going to just Control-T, toggle it, and it basically coasts it to a stop. To recover from that, put this back on. You would drop the enable, re-enable it. It's going back up to speed. And this time we'll drop the ramp speed. We'll see what the reaction is after that. So we're at 8,000 RPM. And toggle. So it's a little quicker. And that's it. That's all there is to it. You want to drop the enable, no faults, everything's ready to go.